Good morning. Sorry, actually we have preponed the class. Actually, I had some hectic schedule today, so I thought not to have any gap. So we'll start the lecture just after 2 minutes, and we will join. Let me share the link with them. Is everything fair? Okay, so let's start the lecture. Dear fellows, it's a very important session for this our optional. What happens is sometimes they ask questions from the improper integrals directly, and sometimes you may have, sometimes yes, occasionally you may have questions indirectly in your optional as well. So what I'm gonna do here is now I will try to decode this topic holistically. Within next 40-50 minutes, we'll be able to do that. And with this completion, we will have a sense of completeness. And completeness is what? So if you observe, till now we started from studying real sequences. Apart from the chapter 1 set theory, real sequences के अंदर we have talked about convergence and divergence. Then we went for infinite series, right? Here also we had talked about convergence, right? After that we moved on the uniform convergence. So when I talked about in the just previous lecture RL12 itself, uniform convergence, here we were concerned about sequence of functions and series of functions, right? So till now we have covered the things in this connected manner, and I hope each of you who have been consistently attending lectures at this point of time they will have a sense, they will have a crystal clear picture in their mind कि what actually convergence includes for our mathematics optional, right? So in continuation of that, today's topic is today we are interested in convergence of improper integrals. Fair? This is the topic for today. Now, if you feel like when I decoded this lecture series according to the optional, initially I told you for me, calculus and analysis is a theme, right or not? So when I talk like this, many of you might be thinking कि सर पता नहीं क्या बोल रहे हैं करके, calculus और analysis में थोड़ा थोड़ा तो common होता है, but how we will comprehend that? But over the classes, over the period of lectures, you have observed, like when we went for differential calculus, please recall, when we went for differential calculus, what I did is functions के case में I went with the theoretical aspects as well, be it epsilon delta definition, be it Taylor's theorem का proof, be it the questions based on the monotonic nature. So all those compartment which comes under the functions in the real analysis, those we have already covered in the differential calculus and in the integral calculus. At that time I told you when we will go for real analysis, although people say it is very bulky topic, but I will prove it is not at all, because whatever efforts we have put in the differential calculus, those are gonna impact much over this. So when I started this real analysis, clearly I told you that we will work in blocks. The block 1 I told you that is of general things, basically the topology part in which we have studied the set theory on an average, right? We took time over that. I tried to explain everything. Moreover, I was very much concerned कि आपके अंदर वो habit develop हो पाए. You people should have that attitude how to deal the real analysis, right? So initial 3 to 4 lectures I was completely dedicated towards that development in you, in your attitude. Once you developed that, then I went for the second block and I call that as a sequences and series. So first block in real analysis, it was set theory. The second block, that is sequences and series. So when you talk about the second block, this looks like this. These 3 topics we have done. Today we are going to do this. While doing these 3 topics, you people have observed the monotonic nature of my teaching methodologies. If you correctly recall, I have invested my 70% energy over real sequences. Say yes or no. Then I went for series. I told you a series is nothing but a sequence of partial sums only. So 20% energy went on this. Fair? Then I told you whatever the tests of convergence in this chapter, whatever the tests for convergence in this chapter, those will be applied, because here we have nothing new. It is just a sequence of functions, series of functions. So whatever tests, whatever the knowledge we carried from here itself, that is gonna be reflected here in the different forms. So if you correctly recall the previous lecture RL12, there I told you uniform convergence very systematically, why this came into picture, what is the need of point-wise convergence, what happens if some sequence or series is point-wise convergence but not uniformly convergent, then how does it gonna impact on the continuity of limit function, differentiability of limit functions, and integrability of that. Here in the uniform convergence, we had Cauchy's criteria for convergence for this. Ultimately, if you go for the UPSC syllabus in the forest services, sometimes they touch the proof kind of material. I went with that as well, and I tried my best to develop that habit कि definitions कैसे लिखना है, how to write definition. Because if you have observed over these three chapters, continuously I was focusing on writing definitions again and again. The reason was not that I have to waste the energy or time. The reason was these are the things for which you are attending this lecture series. These are the things which are usually missed by the people who are very good in formula solving and numerical solving. So here I am trying to be very comprehensive without compromising the conceptual clarity, and for those formula type of questions also I solved examples for you just to have the prototypes ki how the MN test work, how does it work for that M test for this convergence of series, uniform convergence. So these are the things we have done till now. Why I have spoken this much? Because I feel कि if I am putting my best efforts over this lecture series, not because I know the real analysis. It is not like that. It is all about I feel this mathematics optional and I want you to feel this mathematics optional कि things are very systematic in nature. अभी होगा क्या? इंटीग्रल कैलकुलस में इसको पढ़ेंगे, फिर रियल एनालिसिस में इसको पढ़ेंगे, फिर कभी एक अलग चैप्टर इसका पढ़ेंगे, फिर कभी एक अलग चैप्टर इसका पढ़ेंगे. And end of the day you land up with the whole blank scenarios. You don't know how to connect the dots systematically. Getting my points? So here I am doing nothing, my dear fellows. मैं आपको बार बार ये चीज इसलिए बोल रहा हूँ क्योंकि आपको ये हैबिट डेवलप करनी है अपने अंदर कि मैथ्स ऑप्शनल में जो र्यूमर क्रिएट कर देते हैं, इट इज नॉट लाइक दैट. इट डिपेंड्स ऑन योर गाइड वेदर ही इज प्रिपेयरिंग इन द राइट वे और नॉट. चलिए, so this was our second block in real analysis. First block was set theory. अब आते हैं इस चैप्टर के ऊपर, कन्वर्जेंस ऑफ इम्प्रॉपर इंटीग्रल. चलिए ध्यान से देखेंगे, पहले बहुत बड़ा टॉपिक नहीं है, जस्ट वी हैव टू समराइज दैट. जस्ट मुझे 1 मिनट दे देंगे. लेट मी शेयर द थिंग्स. एक्चुअली स्टफ इज एक सेकंड देना बस. चलिए, so what happens dear fellow, sorry actually stop for this. So improper integral is a very lovely topic, very short one, but if you don't have the right way to prepare ना, you will feel कि यार क्या बकवास टॉपिक, मतलब कितना पढ़ना है करके. Okay, so within the next 20 minutes I will summarize the whole picture of improper integrals. So just put down your pen and copy, listen my words now. So let's start. देखिए ध्यान से. The first thing is improper integrals are what? Clear? देखना ध्यान से सारे लोग, be on the board please everyone. When you talk about improper integrals, देखिए ध्यान से. Suppose that I have an integration a to b f of x dx. We may have different cases. देखिए ध्यान से, be on the board please. We may have different cases for such integration. A to b is finite. ठीक है, पहले को infinite ले लेते हैं, फिर bounded ले लेंगे. The interval is finite. Interval of what? Interval of integration. Interval of integration is finite and f of x is bounded. That may be a case, right? Other case may be interval is finite and f of x is unbounded. Where? At some point of interval. The other case may be is infinite and f of x is also unbounded. Fair? अब ध्यान से देखिए. What happens, my dear fellows? This is altogether different category. Basically, we need to discuss these things. This is called improper integral of first kind. This is called improper integral of second kind. For these two kinds, improper integrals of first kind, improper integrals of second kind, we need to have some instrument to check the convergence. Clear है अभी? So we will deal these as block first, these as block second. Fair? अब आप कहेंगे कि सर फॉर एग्जाम्पल लेट्स ट्राई टू अंडरस्टैंड इट. फॉर एग्जाम्पल देखिएगा ध्यान से. Suppose that if you have 1 to infinity sin x upon x dx. Fair? So if you observe you may have, let's say, 0 to 3 1 upon x minus 2 into x minus 5 dx. Observe limits of integration, that is infinite, but f of x equals 1 upon x is bounded in 1 to infinity, because 1 upon infinity will tend to 0. So this is an improper integral of first kind. Fair? Now come here. देखिएगा, limits of integration are 0 to 3, that is finite, but f of x equals is unbounded at x equals to 2, which is a point inside that interval, right? So this is an improper integral of second. Fair, dear fellows? So improper integral of first kind, improper integral of second kind, we are done. अभी आप समझिए, अब हमारा टास्क क्या है? टू चेक द कन्वर्जेंस. अब कन्वर्जेंस का मीनिंग क्या होता है? We need to have idea about that. So before that, I would like to write a heading here: proper integral. ठीक है? So a to b fx dx is said to be proper integral if a to b is finite and f of x is bounded in a to b. Moreover, the value a to b fx dx is some finite value. So we may have in this word some proper integrals and improper integrals. if you have a proper integral, my dear fellows, so what to notice here is proper integrals are always convergent. Clear? Convergence का meaning we have in our mind from the lecture 1 itself, this sequences का lecture itself. Convergence means that has some finite value. So if you have proper integrals, then those are always convergent. So there is no need to study about convergence of proper integral because automatically those are satisfied. But improper integrals may be convergent or may not. Fair? So note, we are interested in studying convergence of improper integrals of both kinds. Fair? रुकिए अभी थोड़ा सा ध्यान रखिए, ठीक है? What happens, my dear fellows? देखिए ध्यान से, just wait a minute. Be on the board, please. अब कन्वर्जेंस ऑफ इम्प्रॉपर इंटीग्रल का डेफिनेशन पढ़ने जा रहे हैं, which we have in our blood till now, है ना? Convergence of a to b fx dx. So what does that mean? देखिए ध्यान से, an improper integral a to b fx dx is said to be convergent if for every given epsilon greater than 0 there exists m belongs to z plus such that modulus of a to b, यहाँ पर आप a to infinity भी डाल सकते हैं, कुछ भी जो भी आपको चाहिए होगा, f of x माइनस f of x, या फिर ये कन्वर्स करेगा मान लो i लेस देन एप्सिलॉन for b greater or equal to m. So this implies a to b f of x dx, this converges to the value I. Fair? So thing is, my dear fellows, when you talk about convergence of improper integral, it is the same reflection of the things which we started from the sequences का convergence का definition. Right or not? बोलो yes or no? So these things are in our blood now, right? चलिए अब आराम से लिख लीजिए. Now we will go for test of convergence. What is the next target? Next is test for convergence. So this is the whole peripheral of this chapter. Please note it down. Is that everything visible? Let me check it. ऊपर वाला पार्ट दिख रहा है? Please write every word. Don't miss anything. Okay. ऊपर से तो आपने लिख ही दिया होगा, राइट? तो नीचे वाला पार्ट ही कर देते हैं. Okay, everyone, is that noted? Okay, yes. So let's move on. So abhi the picture is clear. The peripheral of the chapter is clear to all. Okay, dear fellows. So let's move now on the convergence the test. Clear? You people can keep writing with me only, okay? क्योंकि अभी we have that much clarity in our mind कि we know how to write the things. So what I am trying to do here, as nothing to just like undergraduate student एक एक टेस्ट करके एक दिन में एक टेस्ट पढ़ेंगे करके, not like that. I'll be writing all 3 tests in one go. Here, then we will be seeing the examples of that, and the same things we will reflect for that. What is the doubt, Shivu? अच्छा देख नहीं रहा, ओके ओके ओके, सॉरी. just wait a minute please. थोड़ा सा क्योंकि सेटिंग एक बार चेंज कर देंगे. अभी दिख रहा है? सॉरी सॉरी. So what I was saying is, dear fellows, as the job we have already done for sequences, series, uniform, convergent, the same things are gonna be reflected again. So I'll be writing those tests in one go. Hope these things will be crystal clear for all. Then we will take prototype examples in support of that. Yeah. Chale. So comparison test for improper integral of first kind. So obviously improper integrals of first kind will be looking of this form, right? Where f of x is bounded. Chale. So what is that test? Let's write the statement of that. लिखेंगे इसको. If f of x and g of x be two functions which are bounded and integrable, let f of x and g of x are two functions which are bounded and integrable in a to infinity. ठीक है? Also let gx be positive in a to infinity. ठीक है? The number first point which we need to remember is, if modulus of f of x is obviously g of x positive है तो उसका मॉडुलस लेंगे, the same thing will be reflected for x greater or equal to a, where and a to infinity gx dx is convergent, then a to infinity fx dx is also convergent. If you correctly recall, which we studied in the comparison test for infinite series, शुभम चौबे, क्या पढ़ा था हमने? Comparison test for infinite series में we had studied कि we had some series un which is less or equal to k times bn, right? If summation bn is convergent, then summation un is also convergent. And what we worked for bn? For Vn observation, we studied comparison series, that is summation 1 upon n का power p. Right or not? यही तो बात थी. बोलो. So the same things are reflected here, only the notations changed. है ना? अब आप यहां पर आइए. Second point will be what? अगर छोटा वाला ही डाइवर्जेंट हो गया तो बड़ा वाला भी डाइवर्जेंट होगा. इफ a to infinity fx dx is divergent, then a to infinity gx dx will also be divergent. Right? So if you want to correctly recall comparison test for positive term series summation un, where un right. So please write down these two words so that you people are in the habit of recalling the things exactly. और दिमाग में ये ना हो कि यार बहुत फॉर्मूले हैं. Because as a student I had to have, like I used to have this feeling कि there are many formulas, यार confusion ही confusion है. कुछ confusion नहीं है. Only the way you studied that was wrong. Clear? Please note down. Check out. So the second test is written like that. This is the approach. So comparison test looks like this. इसका एक अदर फॉर्म भी होता है, वो भी मैं लिख देता हूँ. अभी things are mechanical. Whatever you needed from my side, I have already done that. Fair? अब तो सीधा मैकेनिकल टाइप का चीज. Please keep writing. This also we did in the series as well, right? यहाँ पर हम क्या करते थे? Here we observe the comparison series taken for summation Vn as summation n का power p, right? This is the recalling part. So if you talk about here, सो इन केस ऑफ कंपैरिजन इंटीग्रल क्या होता है उसके लिए लिख देंगे so this is the whole picture of comparison test. Is that noted, everyone? Okay. So what I am like planning here is I'll try to give all the tests at one go. Then we will go for solving problems. Okay. क्योंकि अदरवाइज वो बहुत लेंथी सा चैप्टर लगेगा पता नहीं क्या क्या करना है करके. And if we will do the problems holistically, na, then only we will realize how to perform in the exam hall. एक एक टेस्ट करके करेंगे तो फिर वो कभी फीलिंग ही नहीं आएगा. Please write down here a is greater than 0. Okay, here a is greater than 0. So let's write test 2, that is the mu test. Okay, so इसको लिखेंगे if there exists a number mu greater than 1 such that limit x tends to infinity x power mu of x exists. Okay, the second point is if there exists a number mu less or equal to 1 such that exists and non-zero. So please highlight this. Here only it won't exist, the non-zero part is not required. Then a to infinity fx dx is conversant. Then a to infinity fx dx is divergent. अच्छा, divergent का मीनिंग समझते हैं ना? That goes to either plus infinity or minus infinity, right? So this is a crucial point here. While applying the mu test, the value of mu is usually, there is no standard rule, usually taken to be the highest power of x in the denominator minus the highest power of x in numerator. See, what I have decided is, as I have done the theoretical aspects very well through the sequences itself, I have developed those attitude in you. So for convergence of improper integral, the document is typed. I will share that document. If you have time, based on our learnings, based on our proof doings, you can go for these proofs as well. Just 2-3 liner proofs are there, not more than that. Okay? So don't think कि मैं proof skip कर रहा हूँ. I have already done a lot for you. Now things are just like doable. Please note down. इसको important mark कर लेंगे क्योंकि यहाँ mu कैसे observe किया जाता है, that is the point. So this is mu test. there exists a number mu greater than 1, highlight this, mu less or equal to 1 के लिए we need this limit as non-zero as well. So I would like to do कि इसको highlight कर दीजिए करके. This test is noted, everyone. ये लिख दिया सबने. Now we have two tests. Those are the final tests. Very good thing is here, whatever the test का nature, the same thing will be reflected for second kind. So the first kind में थोड़ा सा मनरेगा मजदूरी you may feel, but it will be settled within the first kind itself, as far as remembering is concerned. So let's have the next test. Test 3 and test 4 मैं एक ही साथ लिखता हूँ. पहले है Agle's test. So what is the statement for this? A to infinity fx dx अपने पास इंटीग्रल है. Obviously a is greater than 0 है. F of x is bounded and integrable in a to infinity. This is the information we have. देखिएगा ध्यान से how Agle's test work. If a to infinity fx dx converges, इसको डिकोड करना मेन गेम है बस और कुछ नहीं. And phi of x is bounded and monotonic. Phi of x is bounded and monotonic for then a to infinity f of x phi x dx is convergent. So कैसे पहचानेंगे? इनका पहचान क्या है? Product form of integrands. That is the key word for Agle's and Dirichlet test. Whenever we want to check the convergence of a to infinity fx phi x dx type, so if this thing holds, देखिए ध्यान से, then this thing will hold. So how to recognize? Product form में whenever you want to check the convergence, then you will go for Abel's test or Dirichlet's test. So how the Dirichlet works? उसको भी लिख लेते हैं. आराम से देख लेंगे। 3 and 4 दोनों के लिए प्रोडक्ट फॉर्म के इंटीग्रल्स जब आते हैं, then we use these Abels or Dirichlet. If you observe here, dear fellows, in the Abels test we need convergence of this, whereas here in the Dirichlet test we need boundedness of this f of x का वैल्यू, clear? Whereas phi of x के लिए we need boundedness, whereas यहाँ पर bounded and monotonic for that phi x. So I would like to suggest you behave like a child here. ठीक है, आराम से एक एक कीवर्ड को मैंने आपको बता दिया है, what is the difference. Ultimately you have to do Ratta Mar Zindabad because that is the demand of exam. You have to perform. Please set it up. Is that noted? देख लीजिए अभी इसको. Okay, dears. So abhi what I do, I take prototype examples so that things are completed in some sense, and how these methods work. So फटाफट हम उसको कर देंगे. You people will also keep writing with me, okay? फटाफट लिखेंगे उनको. इनमें कुछ है नहीं अब, बहुत ज़्यादा 3-5. So let's have examples. The question is dx upon x under root 1 plus x square. देखेंगे जस्ट फर्स्ट एग्जांपल है तो थोड़ा सा मैं बोलने की कोशिश करूंगा, अदरवाइज थिंग्स आर ओके. You are the word please everyone. x under root 1 plus x square. चलिए देखिए ध्यान से. So how we think. You are the word please. Although we may have different tests, तो अभी मैं स्टार्टिंग से like I would like to tell you, if comparison works smoothly, we will go by that. If comparison test does not work, then we will go for new test. If that does not work smoothly, I will go for this Abels or Dirichlet. If everything fails, I will try to calculate the integral. You are getting my point? If all tests are failed, then I will try to solve this integral by the integration itself. And if the value comes out to be finite number, I will say this is convergent. right or not? So these are the instrument we carry. This is how we think. So सबसे पहला जो अपने दिमाग में आएगा वो आएगा कंपैरिजन टेस्ट, राइट? सो देखेंगे ध्यान से, a to infinity fx dx, it is given as a to infinity dx upon x under root. So this implies f of x equals 1 upon x under root 1 plus x square. अब देखिए, like very calm and composed you should be here. How to have the feelings for comparison? Comparison is all about, if you observe, कि modulus of f of x is less or equal to z of x, modulus of f of x is greater or equal to z of x. ये बैक ऑफ द माइंड में चल रहा है, बोलिए. So means I want to have, that is, we want to have such gx, और gx भी किस फॉर्म में चाहिए? टाइप कंपैरिजन सीरीज, right or not? So if you observe this thing, let's be here. देखिए ध्यान से, what I do is, if I observe modulus of f of x, this will become modulus of x under root 1 plus x square. ध्यान से देखना, this can be treated as 1 upon, if I take x square outside, so this will come x outside of under root, it will become 1 upon x square plus 1. Check it out, dear fellows. So what you have here is, you have some expression like this. One thing is clearly visible कि if I am able to have this in the form, ध्यान से देखना, if I am able to have, I will mark a star here so that you can develop that habit. Shibu Jaishwal, देखेंगे यहाँ ध्यान से, and again it will come on practice different examples. If I am able to do so such that z of x equals to x square, my job is done. Say yes or no. Say yes or no. That means I have to discuss about this thing now. देखिए ध्यान से. If you talk about 1 upon x square plus 1, see Jaishwal, this is a quantity greater than 1 or not? अरे बोलो हाँ या ना. So 1 upon x under root 1 upon x square plus 1, that value, if you observe, अगर मैं इसको अपॉन में लेकर आऊंगा, so that will be less than 1 or not? कोई दिक्कत? शिबू जयसवाल, कोई दिक्कत? So this can be written as 1 upon x square less than के साथ. Why? So here we are trying to get and gx as comparison integral, right? For this, तो ये भाई ये है mental exercise. When you will go through different examples, this exercise will be sharpened, है ना? Just wait a minute, I guess. Sorry. एक मिनट वेट. I'm sorry, actually the laptop battery was disconnected. अभी I guess we have the things. Clear है अभी सभी को? So this is g of x now. अभी p greater than 1 आप क्या यूज करेंगे? We know that integration a to infinity 1 upon x square dx is convergent. So integration a to infinity fx dx, that is a to infinity 1 upon x under root 1 plus x square dx is also convergent. I guess things will be crystal clear to all. Say yes or no, everyone. चलिए, so let's have an example now to substantiate the next test. प्लीज कीप राइटिंग विद मी फास्ट, क्योंकि मुझे ना 12:30 को छोड़ना होगा वापस से, इधर से निकलना पड़ेगा. So this is the point, like where you have to observe. First you will manage the terms like this. Now suppose that there would be some x ka power here. You will take that denominator minus numerator that I have already taken as a note in the mu test. Right or not? So after doing that management, we will take the mu. Mu will be x ka power in the denominator minus x ka power in the numerator. So here x power 0. So I have taken that like this. Now we will go for checking ki what is happening with this. So this will be converted to बच्चा वाला काम है. So this got cancelled. 1 upon infinity is 0. So 1 upon 0 plus 1, that is 1. That comes out as 1. So if you observe by the mu test, what I told you, if for mu greater than 1, it is divergent. Oh, sorry, convergent. So this is non-zero, which is non-zero finite. So by mu test 1 to infinity dx upon x power 1 by 3 is divergent. क्यों? mu is 5 by 6, which is less than 1. फटाफट लिख देंगे पहले बच्चे इसको, बहुत जल्दी से लिखेंगे. केवल एक ही स्टेप होता है, टर्म्स को मैनेज करके म्यू लिखना, फिर ये लिमिट चेक करना, और म्यू टेस्ट को याद रखेंगे, देन ओनली यू विल बी एबल टू इंटरप्रेट, अदरवाइज नहीं. So based on the different examples are given, the PDF I will share in the group itself, but वो रात को शेयर करूंगा, अभी मेरे को बैक टू बैक लेक्चर्स है इसलिए टाइम नहीं मिलेगा. सिंपल एग्जामिनेशंस उस पर भी है, बीटा फंक्शन पर भी कोई इशू नहीं उसके अंदर. Check out this. So Dirichlet's test and Abel's test works like this. अभी यहाँ पर क्या होता है, what to be chosen as f of x, what to be chosen as phi of x. Here the crucial point is what to be chosen f of x, phi of x. इंट्यूशन कहां से आएगा? We need f of x bounded monotonic limit x tends to infinity. ठीक है, इसका इंट्यूशन कहां से आएगा? a2x so this is the mental exercise you need to do while checking the convergence of improper integrals of first kind. Please note it out. फटाफट लिख लेंगे बच्चे. Is that done? Amit Kumar. Noted? Fair. So as we discussed in the series, absolute convergence means modulus of integrand also converges, right? तो वो वाला पार्ट तो ओके है. अभी सेकंड काइंड को कैसे डील करना है, लेट्स डू द मेंटल एक्सरसाइज फॉर दैट. चलिए, बी ऑन द बोर्ड प्लीज एवरीवन. सभी लोग बोर्ड पर आएंगे प्लीज. What I told you here, the limits will be finite, but f of x is unbounded at some point, ध्यान से देखिएगा, of a comma b. So it is written as, देखना ध्यान से, let's say वो किसी c पर बाउंडेड है. So we write it as a to b fx dx. ध्यान से देखना, we will write a to c minus epsilon, जहां epsilon is a very small quantity. एफ एक्स डी एक्स प्लस लिमिट एप्सिलॉन टेंड्स टू 0 सी प्लस एप्सिलॉन टू बी एफ ऑफ एक्स डी एक्स। अब आप देखिएगा प्लीज एवरीवन, ऐसे ही इंफिनिटी वाले में भी कई बार a टू इंफिनिटी को दे राइट लिमिट x टेंड्स टू इंफिनिटी a टू x, दैट इज द पॉइंट ऑफ रिप्रेजेंटेशन। यहां पर देखिए what happens, f of x is becoming unbounded at the point c, so what we will do, we will break the integration, we will take limits of integration just before c, so it is represented by c minus epsilon, we will take c plus, to ignore the any impact on the integral we take epsilon tending to 0। अमित कुमार, शुभम चौबे, ये बात क्लियर हुई या नहीं, बोलो। टू इग्नोर द इम्पैक्ट we have taken epsilon tending to 0, ठीक है। अब यहां पर भी क्या होगा, कंपैरिजन टेस्ट होगा, राइट, कंपैरिजन टेस्ट होगा तो कंपैरिजन इंटीग्रल होगा, राइट अमर। अब यहां पे कंपैरिजन इंटीग्रल विल बी ऑफ द फॉर्म लाइक दिस, ठीक है। यहां पर भी न्यू टेस्ट होगा, यहां पर भी अगल्स टेस्ट होगा, यहां पर भी डिरिचलेट्स टेस्ट होगा। फेयर? What I suggest you, the booklet which I will share with you, please prepare, please remember, क्योंकि here story may be different compared to first kind test. For example, mu less than 1 के लिए हो सकता है कन्वर्जेंट निकल कर आए, और हो सकता है mu ग्रेटर देन 1 के लिए डाइवर्जेंट निकल कर आए। सो जस्ट अ हिंट, है ना। ऐसा नहीं है कि पहले वाले याद रखेंगे तो थिंग्स आर डन, बट थिंग इज you have to note down on class notes, ठीक है। फिर क्या करेंगे, प्रोटोटाइप एग्जांपल्स, लाइक टेस्ट वर्क कैसे करेगा उसके लिए कुछ एग्जांपल्स सॉल्व कर लेंगे। फिर तो ऐसा मत सोचिए कि मैं आई एम रनिंग शॉर्ट ऑफ टाइम इसलिए ये बोल दिया, नहीं नहीं, इट वाज ऑलरेडी इन प्लान, मेरे पास 2 घंटे और भी होता, स्टिल आई वुड लाइक टू डू सो। सो व्हाट इज योर जॉब नाउ, convergence के related whatever the story you could have in your UPSC mathematics optional, I have touched every dot of that. Sequences, series, uniform convergence, convergence of improper integral. Now I would like to say you have proper time. आज रात को क्लास नहीं होगा, कल दिन में भी नहीं होगा, कल रात को क्लास करेंगे करके हम। So tomorrow we will have a PYQ session of convergence, और कल मजा आएगा आपने को कि yes we have learned in systematic manner or not. Fair? So till then don't forget to solve examples of the PDFs which I have provided. With the same intent you can go through the examples of convergence of improper integrals as well. I have tried my best. Still, if someone feels कि sir I am doing it first time, I am undergraduate or something like that, please do let me know. I will take one complete problem solving session for you related with the convergence. Otherwise तो कल के सेशन के बाद तो वो सब किल हो ही जाएगा, I am pretty sure. So tomorrow's session is gonna be, tomorrow means the next session is gonna be very important for us. So I hope you got the idea of, अभी just फटाफट share your words, whoever is there, Amit, Kanishk, Shubham, Shibu, everyone. Improper integral का थीम समझ में आया क्या है, मतलब एकदम पिक्चर क्लियर है दिमाग में, प्लीज से यस और नो। तो सुबह सुबह जो एनर्जी डाली गई उसका कुछ फायदा हुआ या नहीं, बस उतना बोलिए। इम्प्रॉपर इंटेग्रल क्रिस्टल क्लियर है पिक्चर की नहीं? चलिए, so it's enough for the day. Enjoy the exercises today and tomorrow. We'll meet by tomorrow. Good luck. Okay, dears. Okay, okay. Bye, bye. But please don't write down. Like don't forget to write these stories. है ना? चारों टेस्ट अपनी कॉपी पर जरूर लिखिए. तभी पिक्चर क्लियर होगा कि म्यू ग्रेटर देन 1, जैसे वहां पर n लेस देन 1 के लिए कंपैरिजन में डाइवर्जेंट कन्वर्जेंट जाता है. फर्स्ट काइंड में ग्रेटर देन 1 के लिए कन्वर्जेंट जाता है. सो लाइक दैट. Okay, dear fellows. Bye. Bye, everyone.